Okay, so let's take a look at page 400, number 7, which says light travels from air into a material at an angle of incidence of 59 degrees. Okay, so it's telling us our theta 1 right here is 59 degrees. It's telling us that this is air, so we can get our N1. If the angle of refraction is 41 degrees, so down here, this is 41 degrees. What is the index of refraction? And then identify the material. Okay, so you're doing N1 sine theta 1 equals N2 sine theta 2. And you're solving for N2, so divide both sides by sine theta 2. So N1 sine theta 1 over sine theta 2. So N1 is air. Look it up on the chart. It's 1.00029. Sine of theta 1 is sine of 59 divided by the sine of theta 2, which is the sine of 41. Punch this in your calculator, and when you do, you should get an N of 1.3069. And then you go back to that page 397, and you look at the chart, and you see that it is ice. Okay? That's number 7. Number 8 says a beam of light travels from air into silicon crystal at an angle of incidence of 72 degrees. So my angle of incidence this time is huge. 72 degrees, and it's going from air into zircon. So that means that we can find both of the indices on the chart. And the question wants to know what is the angle of refraction. So we're looking for the theta 2 down here. So N1 sine theta 1 equals N2 sine theta 2. Solving for sine theta 2, so divide both sides by N2. Okay, so air again, 1.00029. Sine of 72, I think my pen's dying, divided by N2, when you look up zircon on the chart, is 1.92. Okay, and so you're going to get a sine theta 2 of 0.495486. Do second function sine and get theta to be 29.702 degrees. Okay? All right, that was number 7 and 8. Number 9 says, what is the angle of incident of light traveling from air into ethyl alcohol? Okay, so it's going from air into ethyl alcohol. When the angle of refraction is 35. So it's, whoops, be good if I hit the boundary. It's coming in at some angle, and it's coming out at an angle of 35. And we're trying to find theta 1. So N1 sine theta 1 equals N2 sine theta 2. Divide both sides by N1. So sine theta 1 equals N2 sine theta 2 over N1. So ethyl alcohol, when you look it up in the chart, because that's 2, right? Yeah. When you look it up in the chart, is 1.362 sine of 35, and N1 is air, 1.00029 again. You get sine theta 2 to be 0.78, I think that's a 0.98. Do second function sine and get theta 1 to be 51.35 degrees. Okay? Next set of questions, page 405, I believe, number 10, says, a beam of light passes from air into ethyl alcohol. Angle of incidence is 60 degrees. So exactly the same two substances that we had up top. This is 60 degrees, and we're looking for theta 2. And this is air and ethyl alcohol. So N1 sine theta 1 equals N2 sine theta 2. This time we're solving for theta 2, so divide both sides by N2. So N1 sine theta 1 over N2. So air, 1.00029 sine of 60 divided by 1.362. Pen is definitely dying. When you do this, before you take the inverse sine, you get 6.360, and do second function sine and get a theta 2 to be 39.4966 degrees. Okay, and one more. Says a beam of light passing from ethyl alcohol into air. So again, same two substances, only this time it's going from the alcohol into the air. Ethyl alcohol is rubbing alcohol, just in case you were wondering. Angle of refraction is 44.5 degrees. And it wants to know what's the angle of incidence. It's going from more to less. So MLA should be bending away. So this guy should be tinier up here. And you're looking for theta 2. And does it matter when you're drawing it? No. I mean, I like trying to get them roughly like smaller and bigger. I don't go exact. So N1 sine theta 1 equals N2 sine theta 2. My pen is not going to make it to the end. We're solving, I call that 2, but it's really 1. So we're solving for 1. So sine theta 1 is equal to N2 sine theta 2 over N1. N2 is air this time, 1.00029 sine of 44.5. And N1 is ethyl alcohol, 1.362. You will get a sine theta 2 to be 0.51477. And then theta works out to be 30.982. So hopefully these were pretty good and straightforward for you. Okay?